scalability. Scalability in general terms is uh, your system can accept changes, and when we talk about scalability with respect to big data, so as we discussed previously that there are three controllers of big data: observations, features, and classes. So that means these three aspects of these three controllers of the big data, they are always changing, they are always expanding. So, or you can say they are always increasing as well. So when we talk, for example, when we talk about classes, there are always new classes. There is always a data which adds new variety to your data. So that means scalability in terms of big data is something which you cannot avoid. If you are dealing with big data, you must be prepared for the fact that the number of features you have today, it will increase in the future, maybe after 1 month or maybe after 1 year or whatever. So that means there are types of system: high dimensional systems and low dimensional systems. So high dimensional system, normally we say that the system which has a large number of features. So that is a system, or that is a data which is called as high dimensional data. But although there is no general rule of thumb, or there is no general principle regarding that which data can be classified as high dimensional and which data cannot be classified as high dimensional. But some people think that if your number of features are larger than the number of observations, then it can be called as high dimensional data. So if you're, for example, if you have 1000 observations, and your number for each observation you have 1100 or 1500 features, for each observation you have that much feature space, so that can be called as high dimensional. So the typical example of it is that your pictures and videos today in your cell phones or your cameras or whatever you say, in your video streaming applications, it is all high dimensional. All the number of videos may not be huge in your cell phone alone, but the number of features it represents is very large. For example, we say 8K. So 8K resolution, 8,000 pixels on a horizontal plane there. So that means that this is something that we must be prepared for. So when we talk about high dimensional dataset or high dimensional structures, one of the main problem here is that how we can understand such a data. Because for example here, if we talk about text processing, that we want to decide whether some text, some document is a spam document, or you do not require it at all, or it is of some importance. So that means if we want to design a system which can automatically uh, filter the spam text from the normal text, so it has to observe the thousands of words present in the your in a single message. So each word here is a feature. So that means when we take into account a simple document, even one-page document as well, so it may have thousands of words. So and when we talk about thousands of such emails that are being generated daily, and those emails are normally in your junk emails or spam folders. So those emails actually are automatically scrutinized on the basis of the features they have. So that means they will have a certain uh, text types or certain combination of words that result in classifying them into spam email or spam message. Obviously, they will have uh, some characteristics or some textual lines or combination of words that your email system says that okay, this is not good for you guys, this is just a junk message, so they send it to your junk inbox. So that is a typical example of this. So here the big question is that how we can analyze high dimensional structures and whether all the features are relevant to your problem. So these are main objectives of this. So one uh, um, solution to high dimensional structures is to convert it into low dimensional structures. Uh, First of all, the more number of features we have, it becomes very difficult and in terms of computational power, in terms of computing, to derive some patterns from that. So what we see that normally in statistics as well, we when we have a data set or data which we call it as a population, so we derive a sample. So in case of features, we always go for feature subspace. We focus on certain features of the data only and extract those features and build our model or pattern on top of those sub features or subspace. So these are called as dimensional structures. People think that low dimensional structures are easy to compute, and once you have some general, some have once you have some patterns from low dimensional structures, it is easy to scale it to the high dimensional structure, rather than building your structure entirely on the high dimensional data and then scale it down to other structures. So they think that from computation power as well, computing resources as well, you can build multiple small substructures, low dimensional structures, and then scale your model accordingly to the high dimensional structures. So this is called as this is the differentiation between the two. One such technique is the representation learning. Representation learning, as we discussed previously, these are the group of statistical techniques to understand the data, and they are very handy and very useful actually in understanding the data or in even transforming the data. Typical examples are mean, standard deviation, covariance, your box plots, pie charts, histograms. They are all statistical. They are all examples of representation learning. Second thing is feature hashing. Feature hashing is a technique actually where we actually take into account the a subspace of the feature. That means a subset of the data set, and then we build our model on the base of those features and then scale it up to the high dimensional features, whole data set. So this is feature scaling. And okay, once we are done with this, so we come into another thing. We come across another thing, that how these features can be correlated and what measures are important. But before doing that, we must have we cannot jump straight forward into data mining. We must have some questions in mind, general questions in mind. For example, here are some questions outlined for you guys. For example, first thing about the dataset. Whenever something comes up, you need to understand the dataset, whether that dataset is a regular dataset or it's a big dataset. And when we talk about regular data, that means that can be easily analyzed by using your common analysis tools like spreadsheets or any other thing, or maybe simply manually by hand. But when we talk about big data set, we always think that these are all, more in volume, in variety, and velocity as well. So why answering this question is important, because for regular data set we do not need sophisticated technologies most of the times, but for big data we always need certain tools or certain technologies, first to manage that data, then to manipulate that data or mine that data. Okay. Second thing, once you have the understanding of whether the data can be categorized as regular data or big data, the next question you always ask that whether that data set has some classes or separable boundaries within the observations or not. If there are certain classes within the data, then it's good. It is easier to classify that data, or to model that data, or to build or to get some pattern from data. For example, if you have data from of a database which has the features of fruits, different fruits or vegetables, that means that that data set already has the classes built in terms of that whether certain features are classified as apple, or certain features are classified as orange, or this and that. So that is much easier to handle. But on the other hand, when we do not have distinguishable classes in the data, we always look for certain geometric patterns within the data, and that is called as clustering. So when we are trying to find the geometric patterns within the data, uh, although we can find some statistical or geometrical resemblance between the different data points, so that we can say, okay, there are two groups or three groups of data points present in a particular data set. But they are always ambiguous, and there is a huge false positive rate as well. So false rate is always high in that, because we do not know the actual outcome of the data. Although we are forecasting on the on the basis of geometric patterns within the data, but in classification tasks, we already know the outcome, that okay, this is the actual data, and this is the outcome of that. These are the labels of that. So we can compare our model, our predicted or forecasted model, with the actual outcome. But in clustering, actually, we cannot do that, because we only have the data itself, but we do not have the labels for the data. So that means that we cannot compute that, okay, how much error we have. So we always expect that there is a high chance of having a false positive or false negative as in your data. Okay. So scalability, as we discussed today as well, the scalability problem. Scalability, as I mentioned, that whether certain aspects of the data are growing, whether the number of observations are increasing, number of features are increasing, or number of classes are increasing. So does that data set have that problem or not? So if your dataset has that problem, then you adopt certain approaches to counter, or to choose an algorithm which is highly scalable, which is proven to be which is proven to give you a scalable solutions. So as compared to if general algorithm which does not give you scalable solutions at all. Um, Then dimensionality of the data. Dimensionality of the data is very simple. That if your number of features are greater than the number of observation, this is called as a high dimensional data, and this actually changes how we deal with the data. Actually, sometimes we need to extract the information first, or reduce the dimensionality of the data itself, and then go for the model building or pattern mining in the data. So that means that is something we must know about before going into data mining process. So low dimensional structures mean that sometimes you are given the data set which is already in low dimension, and you can use that low dimensional information to construct some high dimensional, you can say, information, high dimensional data set. A very example is that when you in the forensic sciences, what you see that you are given, for example, there is some robbery in the bank, and the robber has covered the face. So in that particular scenario, we only know about his eyes, or maybe his voice. So what forensic sciences say that you can construct the face and voice tune on the base of eyes and the features of the around the eyes, and especially, and if even if your face is covered, you can somehow construct its face, and you can say remaining face. So that means we are only given the portion of where eyes are exposed, or voice recording. So that is a low dimensional data. That means we do not have the entire data set actually. But what we get, if we have data set of the known criminals, or the criminal, or the people who have criminal records, we have their voice notes in the databases, or we have their faces in the databases. So we can easily match, extract information from just eyes, and match them to the whether it is someone who has already has done some who is already convicted of some crime or not. So that is something we do, that we analyze low dimensional structures and to construct the high dimensional structures. So that is also so that is very important from a data processing point of view. If you are just going straightforwardly towards mining the data without understanding what is going beneath, or what is the data set actually about, then you will not be getting any result out of it. So if you look at these 5 6 points, 6 or 7 points, so all of them are actually related to what about related to understanding the data itself. Because once you understand the data, you can easily go towards the next stage. So here some examples are given. For example, so he said these are all questions, 6 7 questions, and they are grouped here according to the structures of the data, how the data is presented, characteristics of the data, scalability of the data, dimensionality of the data, and the existence of meaningful low dimension structures. In general, the machine learning attempts to answer the questions: which class does the observation belong to, and when we have certain classes in the data, that means that is a classification or supervised learning problem, and we go for training and validating our model accordingly. So let's say that there is an example of whether there is a person A or person B whose image is being presented to the system. So this is just for the example. You can just go through that. So um, any question till now?